Yo, what's good, everybody? The Sleuth here, and today me and Stream react and comment on this video explaining white holes. So we're gonna watch this together. I'm gonna react, break it down, and try to actually understand what's going on, because I know I'm not the only one confused by this stuff. If you enjoyed the video, please drop a like and hit subscribe, but for now, just sit back and relax while we get into it. What is a white hole opposite of a black hole?
Celebrated astrophysicist is intently studying the skies in search of his elusive quarry, combing through the thousands of images coming to him from the state-of-the-art International Event Horizon Telescope. Finally, after months and months of searching, he thinks he may have found what he's been looking for all this time. In the images, he sees the telltale signs of a mysterious phenomenon called a black hole. But as he scrutinizes the images captured by the powerful telescope, something doesn't seem quite right. There, right in front of his very eyes, the black hole appears to be burping. The scientist knows this should be impossible. Nothing can escape from a black hole, not even light. That's why they're so hard to find. But here's photographic evidence of matter coming out of a black hole. Could it be that this is not a black hole at all, but the black hole's neglected twin, a white hole? Could this be his chance to once and for all answer the question?
Oh, so it pushes things out? That's what it looks like. But the question is a white hole white or is it black? Because from this picture, it looks like it's still black, which would be even harder to find. Because then you'd have to like watch it and wait for it to push things out. So like, would that also mean like you couldn't be sucked into it? You'd actually be pushed away?
Questions that might have been nagging him through his whole career. What is a white hole? How do they form? How do they work? And do they even exist at all? In 1915, Einstein's field equations turned the world of physics on its head. His theory of relativity described the force of gravity and shattered the prevailing paradigm of the nature of reality. Rather than being rigid, space and time can actually bend and fold, along with the mass of stars and planets. Within a year, scientists had calculated how space-time curves around a single ball of mass, the seeds of what today is called the singularity. Physicists were able to describe how a spherical mass shrunken down to an infinitely dense point could wrap space around it so tightly that a region of space is effectively pinched off from the rest of the universe, creating a no-man's land beyond the event horizon, where the laws of physics no longer apply and the link between cause and effect is shattered. A black hole is an incredibly dense area of space where all matter has been squeezed into an impossibly tiny space called the singularity. This creates such an intense gravitational pull that nothing, not even light, can escape from the black hole's clutches. A tiny black hole might be the size of a single atom, but have a mass equal to a large mountain. Stellar black holes, formed when a dying star collapses in on itself in a supernova, can have a mass of up to 20 times greater than our sun. The largest black holes are called supermassive black holes.
Supermassive. They said the largest black holes are called supermassive. Like, y'all couldn't come up with a better word than that. They're just like, what should we call the largest black holes? Let's call it supermassive. I think a black hole pulls you in, and then everything get pulled. It comes out a white hole somewhere else. So kind of like a wormhole, where it's like a black hole. Are you saying like it's a black hole in like one part of the universe, but like maybe somewhere else there's a white hole that also appears? Is that what you're trying to say?
Galaxy in our universe. The supermassive black hole at the center of our Milky Way galaxy, named Sagittarius A star, has as much mass as 4 million of our suns, all condensed into a tiny ball only as big as a few million Earths. A black hole's event horizon is what we would consider the surface of the black hole, although it's not a surface in the true sense of the word. It's not a membrane or a barrier, but rather the threshold beyond which there is no going back. The event horizon is the point of no return. Nothing that crosses the event horizon can ever come back. Even light cannot escape the black hole once it's past the event horizon. Once something or someone has crossed the event horizon, they will begin the inevitable process of falling toward the black hole's singularity, eventually dissolving into the singularity itself. We can only guess what happens after that. Physicists have been studying black holes for decades and are only just beginning to understand them. Only recently have they turned their attention to the black hole's neglected twin, the white hole. From afar, the white hole would appear identical to its better-known cousin, a black hole. Like a black hole, a white hole might be big or small, might spin or remain stationary, and might be electrically charged. A white hole would also be surrounded by a ring of dust, and a cloud of gas and debris would gather at its event horizon. The key difference between a black hole and a white hole is that white holes burp. Yes, burp. Unlike a black hole from which nothing can escape, matter actually can cross the event horizon and come out of a white hole. It's only in these moments when objects emerge from the
So technically, couldn't you survive? If that's true, I wonder. I wonder if they explain it in this video. But technically, couldn't you survive if like you can cross the event horizon?
white hole, that scientists can definitively say that what they're looking at is a white hole and not a black hole. If a black hole's
You'd have to be able to survive space. I know, that's what I'm saying. I'm saying, like, say we get to that point, and like you get to a white hole, you get sucked in or whatever. Couldn't you technically survive if it just like passes you through? That's what I was wondering. I'm just saying, like, of course we have whatever the technology is. You get to that point of innovation at our technology. But I was just wondering.
event horizon is the point of no return, then the event horizon of a white
Also, I don't think so, because it's still pulling you in to spit you out. Yeah, that's what I wondered. If, like, it's still... I was wondering if the force would still be, like, too strong and still, like, break you apart.
hole could be described as the point of no admission. Nothing can ever cross the event horizon of a white hole and reach the interior. In a black hole, objects in the space outside can cross the event horizon and affect the interior of the black hole. But matter inside the black hole can never again interact with space outside. In a white hole, the reverse holds true. Objects from inside the white hole can cross the event horizon and interact with objects in the space outside of it, but nothing on the outside can ever enter the white hole or affect the inside. This is because a white hole is a black hole's time reversal, according to physicists. A black hole singularity exists in the future, whereas a white hole singularity exists in the past. Since the interior of a white hole is cut off from the universe's past via its event horizon, no outside object or event will ever affect the inside of a white hole. James Bardeen, a black hole pioneer and professor emeritus at the University of Washington, explains the magnitude of this difference. Somehow, it's more disturbing to have a singularity in the past that can affect everything in the outside world, he said.
So basically, like, you go into a black hole, and everything inside the black hole can change the past. What I was saying is like a white hole. Basically, like, things can go in it and change the past. If I'm understanding this right. Now, that's kind of weird. But a black hole, things go in it and I guess change the future. That's kind of interesting.
Scientists had theorized about the existence of black holes for hundreds of years before Einstein's theory of relativity paved the way for physicists to prove their existence. Theoretically, at least, since no light escapes from a black hole, they are invisible to the naked eye. Until very recently, the only way scientists have been able to find evidence of black holes has been to look for signs of their impact on the surrounding universe. Stars, gases, and other space objects behave differently near a black hole than they do elsewhere in the universe, as the black hole's intense gravity pulls on them. Using telescopes equipped with special tools, scientists can pick up a type of high-energy light emitted by objects that interact with the black hole's gravitational forces, and reverberation mapping can measure the radiation given off by the ring of debris that surrounds the black hole, helping physicists pinpoint the location of a black hole, even if they can't see the black hole itself. Finally, in 2019, scientists made a stunning breakthrough in the study of black holes when the International Event Horizon Telescope captured the world's first image of a black hole. Technically, what they captured was the black hole's shadow, since the absence of light reflecting from a black hole makes the black hole itself impossible to see, but nevertheless, this was the world's first solid photographic proof of the existence of black holes. If black holes have finally been proven to be real, does that mean that white holes are a proven fact of the universe too? Well, not exactly. While Einstein's theory of general relativity does describe the existence of both black and white holes, it doesn't explain how a white hole might actually form in space. A black hole forms when a dying star implodes in a supernova, collapsing all of the star's matter into an impossibly tiny area cordoned off from the rest of space. The reverse doesn't quite make sense. The idea of a white hole exploding into a fully functioning star would be a bit like unscrambling an egg. It just wouldn't work. This idea also violates the statistical law that entropy must increase over time. Furthermore, if a white hole did form, the matter it releases when it burps would collide with the matter in orbit around the white hole. These collisions would cause the entire system to collapse into a black hole. Perhaps if white holes do exist, they don't remain as a white hole for long. Hal Haggard, a theoretical physicist at Bard College in New York, has said that a long-lived white hole, I think, is very unlikely. Other scientists have different theories about white holes that help explain some of the inconsistencies. Stephen Hawking discovered back in the 70s that black holes leak energy, which led him to wonder, how do black holes die? And what happens to everything that's been trapped inside of a black hole when it dies? The theory of general relativity holds that nothing can get out of a black hole, but quantum mechanics prevents any information inside a black hole from being deleted. So where does it go? Some have taken this to mean that a white hole is actually the result of a death of a black hole. As a black hole dies, it may become so small as 1 microgram in size, about the mass of a human hair, that it would no longer obey the laws of physics as we know them. This infinitesimally small object would be so small that it would defy gravity, but inside it would hide a cavernous interior full of everything it swallowed in its previous life as a black hole. Its small size and gravity-defying behavior could allow it to remain stable enough to eventually spit out information and matter that had been swallowed by the black hole, becoming a burping white hole instead. If this theory holds true, the universe could one day come to be dominated by white holes. After all of the stars in the universe had been burnt out and imploded into black holes, and then after all those black holes themselves have all died, the universe might be nothing but a set of burping white holes. Thankfully, this could only happen in a universe countless trillions of times older than our universe is currently, so it's not a scenario we need to worry about anytime soon. There are many...
That would be mad weird. Like, all the black holes die, so nothing is getting eaten. But instead they become all white holes, and they just shoot out everything that they've been eating for the past millions and millions of years. That would be crazy.
More questions than answers when it comes to white holes, and that leaves room for plenty of imaginative theories about what a white...
Not gonna lie, I kind of want to see a black hole form. I don't. I'd rather like to live, Jerome. I'd rather like to live. I don't care to see one. It's not on my bucket list. It ain't on my bucket list, man.
White hole actually is. Some scientists actually think that we're currently living inside the ultimate white hole. To these black hole physicists, the behavior of a white hole looks suspiciously similar to a little thing we call the Big Bang. The explosion of matter and energy resulting from the Big Bang that created our universe is remarkably similar to the way theorists suspect that white holes release matter. The geometry is very similar in the two cases, Hal Haggard, the physicist from Bard College, has said, even to the point of being mathematically identical at times. This theory has attracted plenty of criticism, but Haggard intends to follow this rabbit hole to the very end, saying, why wouldn't you investigate whether white holes have interesting consequences? It may be that these consequences aren't what you'd expect, but it would be foolhardy to ignore them. We may still be a long way off from being able to look into a telescope and watch with our own eyes as a white hole burps out matter into the surrounding universe. Although we've only just gotten our first glimpse of a black hole, and though we have yet to even lay eyes on a white hole, scientists will undoubtedly discover more about these mysterious phenomena in the future. If the past has taught us anything, it's that just because we can't see something doesn't mean it's not there. Only time will tell which theory about white holes will prove to be correct, or if we had it completely all wrong. One day, we may get an answer to the question, what is a white hole? But until then, it remains yet another of the countless as yet unsolved mysteries of our vast and unknowable universe. If you thought this video was fascinating, you'll definitely want to...
It's going to be so far in the future, though. Like, I doubt we ever find anything out about that anytime soon. You know? I don't know, man. W video, though. It's pretty cool. Alright, that's gonna do it for this video. White holes are way crazier than I thought. If y'all enjoyed the reaction, make sure you drop a like, hit subscribe, and leave a comment. And if you want to watch stuff like this live, or play games with me, pull up to the streams. All my links are down below in the description. But I'll see y'all in the next one. Peace out, everybody, and bye!